Hey everyone, Mrs. Garcia here. I just want to quickly remind you that your name needs to be in the upper right hand corner in pen. And I also want to remind you that your notes must look just like mine in order to obtain credit. So make sure if you need to, you can pause right now and write all this stuff I have on there. But make sure you're following along with me, keeping up and pausing as you need to make sure that your notes look just like mine to get that credit. Okay, let's go ahead and get started. So remember that slope is rise over run. Okay, in other words, change in y over change in x, or delta y over delta x. That's what those triangles stand for, change or delta. Okay, which can be defined with the formula y2 minus y1 over x2 minus x1. You could actually even say y1 minus y2 as long as you go in the same order here and say x1 minus x2. So like I said, it's interchangeable as long as whatever order, if you go 2 and 1 on top, you must go 2 and 1 on bottom. If you go 1 and 2 on top, you must go 1 and 2 on bottom. Okay, and hopefully you remember that you also sometimes see the variable m for slope, kind of like y equals mx plus b in our slope-intercept form. Okay, so let's go ahead and get started with a couple of examples. So on these first few examples, we're going to find the slope of the line containing the given points. So here's the deal. You're given ordered pairs. You don't have a graph, right? So yeah, sure, we could graph these, draw the line through the points, and count the slope, count the rise or fall over the run. But in this case, we're going to use algebra. We're going to use our formula here. So I've went ahead and I've already labeled x1, y1, remember x and y, and then x2, y2. Now, could I have done x2, y2 here and x1, y1 here? Yeah, and actually we're going to do it on the next problem. I'm going to put x2 in front, y2 in front, and x1 and y1 in back, just so you see it doesn't matter which way you do it, as long as if this is 2, this is 2, and if this is 1, this is 1. Okay, so let's go ahead and use our formula for change in y over change in x, y2 minus y1. So y2 is 1 minus y1 is 0 over x2 is negative 3 minus x1 is minus negative 2. So remember, when you minus a negative, that means you're going to add. So we would have 1 minus 0, which is 1, over negative 3 plus 2, which would be negative 1. So this equals negative 1. 1 over negative 1 equals negative 1. And typically, I don't like working across. You should, when possible, work down. But in this case, we don't have much space, so we had to. So our final answer is change in y over change in x equals negative 1. So go ahead and box that up. All right, so like I said, in this one, we started with the x2 and x and y2 in front. That's okay. All right, so change in y over change in x would be y2, so 2 minus y1, 2, over x2, which is negative 1, minus x1, so minus 3. All right, so 2 minus 2 is 0 over negative 1 minus 3 is negative 4. And when we have 0 in the numerator, 0 over anything other than 0 is just 0. So our change in y over change in x is 0. And hopefully you remember that a horizontal line is what gives us a 0 slope. So that would represent a horizontal line if I graphed it. And how, another way you can tell that is because notice the y's were the same. The y's were the same. Those 2 points create a horizontal line. Okay, on number 3, we've already got our x1 and y1 and x2 and y2 labeled. Let's find our change in y over change in x. So y2 is 1 minus y1 is 4. And then x2 minus x1. So we have 1 minus 4, which is negative 3, over 0. If we have 0 in the denominator, however, that's an undefined situation. So for our final answer for this one, we'll say change in y over change in x equals undefined. In a way, we recognize that on a graph, like we'll see below here in a minute, is that's a vertical line. So an undefined slope, it comes from a vertical line. A vertical line has an undefined slope. And how we should have known that this was a vertical line is because these x's, it's kind of not very good, these x's were the same. Okay, so these x's here, x's were the same. Okay, that's how we should have known that made a vertical line. Okay, so next problem, number 4. So what I've done here is, since this is a mapping and there's 3 points available, you can pick any 2. I don't mind which 2 you pick. I just picked the first 2, 0, -2, and 4, -5. You can use the third point if you want and follow along with me and make sure you get the same answer, but we should. Okay, so to find change in y over change in x, we'll do y2 minus y1, so minus a negative turns positive, over x2 minus x1. So this will become -3 over 4, so -3/4. So our change in y over change in x equals -3/4. All right, let's move along to the graphing aspect. So graph the following equations, and of course I put up here to remind you, we'll graph using y equals mx plus b, and state the slope and y-intercept. Okay, for my graphs in my class, you will need a minimum, I want you to write this, because your notes should look just like mine, a minimum of 3 points and a straight edge every time. Okay, so again, reminder that we want to get these equations in slope-intercept form when possible. So here we want to isolate this y. That means we're going to have to move over the +8. Okay, and specifically it's going to go in the back because that's going to be our y-intercept. That's not what's attached to the x. Okay, so we'll write 2y stays, drags down, equals the x goes in front, and then that +8 will turn to a -8 when it jumps across the equal sign. And now to completely isolate the y, we'll divide both sides by 2. I'll divide the left by 2, and what I do to the left, I must do to the right. But here's where we have to do this cheesy thing that I call sharing the love. So you've got to divide both terms on the right by 2. So the x term and the -8 term both need to get divided by 2. So I call that sharing the love because it looks like a heart. All right, so 2 divided by 2 is 1, and we don't need to write the implied 1 here for y. So y equals, there's an implied 1 here, so what is 1 divided by 2? It's 1/2 x. Don't forget the x. Here's the deal. Your x either needs to go in the numerator, like you can erase the 1 or put 1x in the numerator, or if it's off to the side and not in the fraction, it needs to look more like it's in the numerator. Y'all, if your x looks like it's in the denominator, I'll count it wrong because that's a rational graph, something we're going to learn later in Algebra 2. And it needs to be in the numerator, which means a linear graph. So make sure that your x looks like it's in the numerator. Okay, then lastly, -8 divided by 2 is -4. So of course it said to state the slope and y-intercept, so I'm going to do that first. So my slope, my change in y over change in x is 1/2. My slope is 1/2. My y-intercept is an ordered pair that's always represented y-intercept with an x value of 0, so 0, -4. My y-intercept is the ordered pair 0, -4. So make sure you always represent it like that, like an ordered pair, or else again that would be counted wrong because you wouldn't just put the value -4. You want to make sure and use an ordered pair. Okay, so again, make sure you're using the notation I'm using. All right, so now let's talk about the slope. The slope is positive. So again, rise over run. Positive means I'm going to go in positive direction. So that would be I'm going to rise, I'm going to go up 1, and then I'm going to go right 2 because right is a positive direction. So I'm going to rise 1, I'm going to go in that positive direction, and then I'm going to go right 2. Okay, and then if I want more than 3 points, I want to fill it out. Of course, to stay in line with this, I would go down 1, left 2. And that's okay because down is a negative direction, left is a negative direction, and a negative over a negative makes a positive. So how cool is that? All right, so I've got my minimum of 3 points. I'm using my straight edge, and of course I want to put arrows on both ends to define that this line doesn't end at the end of the graph. So arrows on both ends. All right, so that's that. Let's move on to number 6. Okay, on number 6, let's go ahead and get our equation in slope-intercept form. So that means you're going to need to divide both sides by 2. Okay, and of course this 2 over 2 turns to 1. We don't need to write the 1 it's already implied in front of y. So y equals, and then I'm going to, I know, so cheesy, but it works, right? Share the love, make that heart, divide both terms by 2. So that would be -3 over 2x, -3/2 x. Make sure that x looks like it's in the numerator. And then 4 over 2 is 2. Okay, of course my slope is -3/2. Make sure you never put the x there. That's not part of the slope. Okay, so -3/2 is my slope, my change in y over change in x, and my y-intercept is the ordered pair 0, 2. So 0, 2, of course I'll plot that first. And again, make sure on your paper, on your quizzes, on everything that you use this type of notation. All right, so then I'm going in the negative direction first and then positive. So the 3 is negative, the 2 is positive. So I will fall 3 and I'll go positive, I'll go right 2. So fall 3, right 2. Okay, and again, if I want to complete more points to stay in line with these points, of course I'd go rise 3 and left 2, because again, that's a positive direction, but then a negative direction, and a positive over a negative would also make a negative, just like this. Okay, so now I'm going to use my straight edge. And another way, if the slope thing is confusing you about the positive and negative directions and such, of course you can always see me, but another thing is check your graph, like read it left to right. Is the graph doing what it's supposed to be doing? From left to right, a negative slope should be falling, and it is. From left to right, a positive slope should be climbing, and it is. So check yourself, okay? All right, let's look at number 7. On number 7, we're not going to be able to put this in slope-intercept form because we just have a single variable equals a number, so we're good, we leave it. Okay, so this is a special case. This variable represents the axis the graph cuts through. Okay, every point on the line has an x value of 2. So we're going to cut through the x-axis at 2, but of course I'm not going to freehand it. I'm going to put a couple of points here, at least 3, right? Because that's the rule. So I'm going to put a couple of points there, and then I'm going to use my straight edge. I'm going to draw my arrows on both ends, of course. Okay, and let's talk about this. Every point on this line has an x value of 2. Would you agree with that? If I pick a random point on this line, that point right there, does it have an x value of 2? Yeah, that's the ordered pair 2, -3. Every single point on that line has an x value of 2, and we cut through the x-axis at 2. What's my change in y over change in x for this graph? Maybe you remember from Algebra 1 being able to draw a U on this because this is an undefined slope. Okay, what's my y-intercept? Why didn't I have an ordered pair written here? Well, because I don't cross through the y-axis at all, so this is not applicable. Okay, I'll never cross through the y-axis. I don't have a y-intercept in this case. All right, moving along. So here on this problem, that's the axis I cut through. So I'm going to cut through the y-axis at 2. And so it'll look something like this. And hopefully you agree with me that every single point on this line, if I pick a random point, if I pick that point, that y value for that coordinate is 2. Okay, and hopefully you remember from Algebra 1 that you can write a z on this, because this is a 0 slope. And what is my ordered pair for the y-intercept? It's 0, 2. All right, let's move on to the back. Okay, so let's remind ourselves that parallel lines have the same slope, while perpendicular lines have opposite reciprocal slopes. And what that means is you take the value and you flip it and you switch the sign. So let's do an example. Given the function y equals 2/3 x minus 1, what is the slope of all lines parallel to this one? How about perpendicular? So if you remember, this is the symbol for parallel. So a parallel slope would equal, well, what's the slope of this line? The slope of this line is 2/3, and remember that parallel lines have the same slope, so a parallel slope would be the same, 2/3. And maybe you remember this is the symbol for perpendicular, so a perpendicular slope, okay, would be flipped and switched. So flip the 2/3 to make it 3/2, and then switch that positive sign to be a negative sign, and then we're done. That's a 2. Does it look like a 2? Okay, last part. Describe what the slope represents in each graph below. Remember to use complete sentences. So I want to remind you that y depends on x. Okay, so just like that is red, y depends on x. Just like I would say, cricket chirps depend on the temperature. Just like I would say, pages left to read depend on the minutes spent reading. Okay, and hopefully that makes sense. Just like I would say those things, to describe the slope, we're going to start with the y. We're going to describe the direction, because in this case with the slope, we know the direction that we're going. And then we're going to end with the x's like we did here. So let me show you what I mean. So the first one, since we're using full sentences, would look like this slope either shows or represents, something like that. This slope shows, and we're going to start with y, the number of cricket chirps. What happens? So what's happening to the y here with this slope? The y values are increasing. So this slope shows the number of cricket chirps increase as, end with the x's, temperature. And what's happening to the temperature? Temperature as we go to the right, as we follow the slope and read a graph like we read a book, left to right. The y's are increasing, but also the x's are increasing. So as temperature increases. Okay, so let's do the next one. This slope shows or represents, okay, start with the y. So this slope slows the pages left to read. What's happening as I read left to right? Well, that's decreasing, decreases. Pages left to read decreases as minutes spent reading. Don't be fooled here. What's happening as I go left to right to my x's? They are increasing. As minutes spent reading increases. Okay, as I go left to right, my x values are increasing. Okay, here, this slope shows the miles traveled increasing, right? As I go left to right, my miles traveled, my y's are increasing as hours, as I go left to right, increase. Last, this slope shows speed. What's happening to speed? What's happening to my y's? Decreasing as the incline. What's happening as I go left to right to my x's? On the right, even though this is falling, the x's are increasing. So as the incline increases. And these should all make sense. Doesn't that make sense that your speed decreases as incline increases? Okay, doesn't it make sense that your pages left to read decreases as the minutes you spent reading increases? Hopefully so.